Okay, we are going to start the sixth section of the fourth chapter, which is going to be over the quadratic equation. But what I would like to do is take what we learned in the previous section and apply it to this section, and really so we can see where the quadratic formula comes from. Because it comes from 100% the process of completing the square. So let's say I have a quadratic equation in this form: ax squared plus bx plus c, and it's equal to 0. Okay, I want to solve for x here and use it in completing the square. So as you can see, I don't really have numbers for a, b, and c, which in a typical problem they would be, but we're using this as a process to show that it works for any set of numbers. It doesn't really matter what kind of numbers they are, they work all the same. So the process we would start would be like, we want the value in front of the x squared to be 1, so we would have to divide everything by a. All right, and so when I do that, I get x squared plus, well, whatever b divided by a is, x plus whatever c divided by a is. And then 0 divided by a would still be 0. Then we would start by removing that c value, whatever the c value here is, to the other side. So we can go ahead and do that. All right, and then we get x squared plus b over a x, and that is equal to the opposite of c over a. Okay, so now as I'm looking at this, to complete the square, we have to find that special c value that we would add into both sides. And it's whatever this value is divided by 2 squared, if you recall. So normally I would have you write in red, b divided by 2 squared. Well, our b value is a little bit different because it's b over a. So all that's going to look like is we're just going to add in b over 2a. This is the same thing, squared to each side. That's our special c value that will allow us to complete the square. So when I do this, I can go ahead and simplify a little bit to get x squared plus b over a x plus this b value divided by 2a squared is equal to opposite of c over a. And then when I simplify this here, I can actually square basically everything in here. So b gets squared, 2 gets squared, and a gets squared. So that's going to turn into b squared over 2 squared is 4, and a squared is just a squared. Okay, so now I have this complicated looking thing, but remember, when we add in that special c value here, it factors down into x plus whatever this inside value is. Remember, we talked about if this was inside part was -2, it would factor into x minus 2. Or if this inside part was plus 5, it would factor into x plus 5 squared. So we can do that exact same thing. This is just going to factor into x plus b over 2a squared. And in my opinion, it would be really nice if I could go ahead and add these terms together just into one concise term. So to be able to do that, we need common denominators. So as I'm looking at my denominator of a and 4a squared, if I multiply this by 4, this becomes 4a. And if I multiply, but that's not the same as 4a squared. So I would need to multiply this by 4 and a. And if I do that, then I'm going to have a common denominator. So I'm going to have to multiply this top and this bottom part of this term here by 4a. Okay, so this just is going to stay the way it is. Well, this would be minus 4ac over 4a squared plus b squared over 4a squared. Okay, so now that I have common denominators, I can just kind of crunch it together. So let's go ahead and do that. Okay, so this would be like b squared minus 4ac, all divided by 4a squared. Okay, and so now that this is just like one concise number, and this is factored into a perfect or a binomial squared, I can just take the square root of each side. So I can take the square root of x plus b over 2a and take the square root of this whole thing here as well. Okay, so luckily, when I square root each side, my square root symbol and my square actually undo each other. So this just becomes x plus b over 2a. And that's going to be equal to, well, when I square root a fraction, that's the same as taking the square root of the top over the square root of the bottom. Okay, now we want to see if we can simplify either that top or bottom. Unfortunately, on the top here, when I doesn't really simplify into anything great. This isn't like a perfect square, binomial, or a difference of squares. This is just kind of what it is. So this is going to have to kind of stay square root of 4ac. So we're going to get x plus b over 2a is equal to, and whenever I square root, you get a positive and a negative. All right, but that bottom does simplify because 4 is a perfect square and a squared is a perfect square. So what is the square root of 4? It is 2. And what is the square root of a squared? It's a. So now that this is about as concise as it can get, let's go ahead and subtract this other part here. So I can go ahead and subtract b over 2a. To get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac divided by 2a. And finally, since I have both parts have a common denominator, I can just kind of condense this into one simplified fraction, and that would be x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And as you can see, that's exactly what x is equal to. So here, through completing the square, we have now derived the quadratic formula. The only thing you need to use the quadratic formula is a quadratic equation with an a value, a b value, and a c value. If you have all three of those, you can just plug in your a value, your b values, and your c values, and it will give you the x values that are that make that equation true. And that is what this entire section is going to be about. We are going to deal with the quadratic formula today with one learning target, it being that you can use the quadratic formula to solve quadratic equations and recognize when the solution will be complex, which it will be complex in the same exact manner that it was in our previous section, which is if you end up square rooting a negative, getting some term of I, that you will have a quadratic equation. So what is the quadratic equation? Well, we just figured it out. And that is if a, b, and c are real numbers and a is not equal to 0, the quadratic formula will give you your x values if you use the opposite of b plus or minus the square root of b squared minus 4ac, and that is all divided by 2 times a. This is your quadratic formula. Okay. Now we're going to talk about the discriminant. And the discriminant is b squared minus 4ac, okay? and that is just this part underneath the square root symbol. And so we want to think about that. We want to think about that discriminant. If that discriminant is positive, okay, that means we're going to be square rooting a positive number. So if we're square rooting a positive number, you're going to get real solutions there. Okay, because really not the only way, but one of the few ways to really only get complex solutions is square rooting a negative number. So if this part that we're taking the square root of is positive, that means we're only getting 2 real solutions. Okay, and what's that graph going to look like? That means I don't know necessarily where. It might open up or it might open down, but that means that that graph is going to be crossing the x-axis at exactly 2 real spots. Spots that you can point to on the graph and say that is the solution and that is the solution to when the equation is equal to 0. Okay, there are times where that inside part is exactly 0. And so when this part is exactly 0, you lose that plus and minus. So you don't get 1 where it's minus b plus this and minus b minus that. This is completely gone because this entire part is 0. So you're only getting an answer opposite of b divided by 2a. And so what does that mean? That means you're just getting 1 real solution. Okay, and what does that mean as far as the graph goes? That means that your graph is, the vertex is going to be on the x-axis. It's just touching it one time. You can point on the graph to where that solution is at, but again, it only touches it one time. Okay, there are times where you're going to get a negative discriminant, so this inside part ends up being negative. Okay, and when you're square rooting a negative, you're going to get a complex number such as I, and that is when your solutions are complex. And when they're complex, you're going to get 2 complex solutions. Okay, and what does that mean? That means that you're not going to find any real numbers that make the y value equal to 0. That parabola, it might open up or it might open down, but the moral of the story is it's not crossing the x-axis, which is the reason why we're getting complex solutions. They're still solutions, they're just complex. Okay, so let's kind of put that into use. Okay, so now we're going to solve each quadratic equation using the quadratic formula, and then we want to determine what kind of solutions our quadratic equation has. Just like any other quadratic equation, we want to have it set equal to 0. We're trying to find the value when it's set equal to 0, though, because that allows us to factor. Really, the only time we don't do that is when we're completing the square. So we want to go ahead for this problem, and we want to add 9 to each side. Okay, now we want to have it, and we should even put a little note. Okay, we always want to have it set equal to 0. Okay, and so now when I'm looking at this, when we complete the square, we want the a value to be 1. When you're using the quadratic formula, as you can see, it's going to work. If you're from our proof that we just started the class with, it is going to work regardless of what your a value is. Okay, so it doesn't matter what your a value is. We started with a generic a value, meaning it could be 1, it could be any number except for 0. And we can go ahead and plug all of this stuff in and find out that we still get a solution. So in this one, there's no need to get the a value to 1. You can just identify your a, b, and c values as is and go. Okay, so we're going to go. That means a is going to be equal to 2 here. B is going to be equal to 11. And c is going to be equal to 9. Okay, and we just want to go ahead and plug in each value into the formula. So I'm going to go ahead and write the formula. It helps me memorize it. And also, then you guys have it right here on your screen to see where I am plugging these numbers in. Okay, so I will often refer to this as the opposite of b because it's not always negative. Okay, so the opposite of b, what's the opposite of my b value? Well, it's going to be negative 11. Okay, and then we're going to go plus or minus the square root of b squared. So b, again, is 11 minus 4 times a, which is 2, and c, which is 9. Okay, and then we're going to divide that by 2 times a. Okay, so then we can just do a little bit of simplifying. Let's go ahead and figure out what this number is right here. So for me, I just like to do the discriminant itself in the calculator. So 11 squared minus 4 times 2 times a, or 9. So again, if your b value is negative, you'll have to put parentheses around that. I believe we see an example like that. Okay, and so then we're just going to hit enter. So that's 49. So now I get x is equal to the opposite of b, or negative 11, plus or minus the square root of 49, all divided by 4. Okay, square root of 49 is a perfect, 49 is a perfect square. So we actually know what that's equal to. So that's going to be equal to negative 11 plus or minus 7 divided by 4. Okay, and then I'm going to finish my work up here. Okay, so we're going to end up getting two answers. We're going to get negative 11 plus 7 divided by 4, and negative 11 minus 7 divided by 4. So let's go ahead and do that. So my first answer is negative 11 plus 7, okay, which is negative 4, and we're going to divide that by 4, which is negative 1. So we get an answer of negative 1. And then we're also going to get an answer of negative 11 minus 7, and then divided by 4, negative 4.5. Okay. First off, these are real solutions. I mean, we can see visually, but I knew they were going to be real solutions because my discriminant was a positive 49. So that really handed off to me that I'm going to have two real solutions. Okay, and so what does that mean? That means my graph is going to cross the x-axis at negative 1. It's also going to cross the x-axis at negative 4.5. Okay, so let's do number 2. Number 2 is very similar. Okay, we still need to set it equal to 0. Try to have your a value be positive. So we're going to move it to the left. So we're going to get 5x squared minus 10x plus 5 is equal to 0. So that means my a value here is 5. My b value is negative 10. And my c value here is 5. Okay, so then we can go ahead and use the formula. That means x is equal to the opposite of b. So the opposite of b, so what's the opposite of negative 10? Well, it's positive 10. So this is going to be a positive 10 plus or minus the square root of b squared. Okay, my b value is negative. So remember, when I'm squaring a negative, particularly with the calculator, you want to put parentheses around it. It's going to group negative 10 together and go negative 10 times negative 10, as opposed to the opposite of 10 squared. Okay, minus 4 times a times c all divided by 2 times a. Okay, so this is x is equal to 10 plus or minus the square root of. Okay, we're going to go ahead and figure out that discriminant in the calculator. So I got to put negative 10 in parentheses. When my b value is negative, you have to put it in the parentheses if you're going to use the calculator. Otherwise, it will come up with just the wrong solution completely. Okay, here is 0. Okay, so we get 0. So that is here divided by 2 times is 10. Okay, the square root of 0 is 0. So here I'm just getting 10 over 10, which means my x value is just equal to 1, meaning I have one real solution. Okay, and again, you can see why. 1, the discriminant is 0, but we lose that plus and minus that we had here. We had plus 7 and minus 7. That created my two solutions. But when the discriminant is 0, it just plus or minus 0 is just going to end up in 10, regardless of whether I add or subtract 0 from it. So then it just becomes 10 divided by 10, which is 1. And that's a real number, so it's a real solution. Okay, why don't you all take a moment, try A and B on your own, and check it with me right now. And so I'm assuming you've already done these, and you're just here to see how you did. And you start by getting all values A, B, and C to the left side of the equal sign. Or setting it equal to 0, rather, is a better way to phrase that. So A is 5. C is negative 3. And B is 16. Okay, and so then here we can go ahead and use our formula. The opposite of B, so that's negative 16. Okay, plus or minus the square root of B squared. Okay, so we don't really have to worry about that parentheses because it's positive. Minus 4 times A, which is 5. Times C, which is negative 3. Okay, and then we're going to divide that all by 2 times A, which is 5. Okay, so that means I'm going to get x is equal to negative 16 plus or minus. So again, we want to throw that discriminant into the calculator. We're going to get 16 squared minus 4 times 5 times negative 3, which is 316. So I get square root of 316 divided by 10. Okay, so this would be an example where you need to simplify the square root. Okay, this is not going to come out to a nice, neat number like 49 did. So let's go ahead and see what we can do. So negative 16 plus or minus. So 316 divides by 4. 4 is a perfect square. So since 4 is a perfect square, is there another perfect square that would divide into 79? I don't think so. Let's check. 79 divided by 4. No, 79 divided by 16. I doubt it. 79 divided by, yeah, that's it. So 4. So we can split this up into, so square root of 316 is the same as the square root of 4 times 79, which is the same as the square root of 4 times the square root of 79, which is the same as 2 square roots of 79. So that's what we would write as 2 square roots of 79. All divided by 10. Okay. And so then as I'm looking at this, you know, it's nice when you get two nice, neat numbers, right? Or one nice, neat number here. Well, this one's a little more complicated. We're going to get negative 16 plus 2 times the square root of 79 divided by 10. And then we're going to get negative 16 minus 2 times the square root of 79 divided by 10. And realistically, we're not going to get very nice answers like this. So, to me, it seems easiest if we just go ahead and call this the answer. So this is going to be my answer here. Now, are these solutions a real or a complex? Well, essentially to answer that question, you asked, did you ever have to take the square root of a negative number in any capacity? And the answer to that is no. So this was 2 real solutions as well. Okay, 2 real solutions, and I would just call this the answer here. This is the exact answer, and I prefer exact answers over decimal approximations. Okay, B, process is the same, so we're just going to start by adding 3. We're going to get 2x squared plus 2x plus 3 is equal to 0. So a is equal to 2. B is also equal to 2. And C is equal to 3. Okay, and so then we're going to get x is equal to the opposite of b, so that's negative 2. So the opposite of positive 2 is negative 2. Oops. Plus or minus the square root of b squared, so that's 2 squared, minus 4 times a times c, all divided by 2. Dang it, I've done that twice in a row. 2 times a. All right. So here I'm going to get x is equal to negative 2 plus or minus the square root of, let's figure out what that discriminant is. So we're going to get 2 squared minus 4 times 2 times 3. And that gives me negative 20. All divided by 4. Okay, so then here, as I look at this, this can be simplified. Okay, so if I have the square root of negative 20, okay, this can be split up into the square root of negative 4 times 5. And I split it up like that because 4 is a perfect square, and negative 4 is also a perfect square. So this becomes 2i times the square root of 5. So what can I do here? I can say that this is negative 2 plus or minus 2i times the square root of 5, all divided by 4. Okay, if you've gotten here, you're doing great. Great work. But there is one little thing. We're dividing each term here by 4, and they all have a factor of 2 in it. So that means I can actually simplify by dividing each term out of 2, just like you would any other fraction. This would technically simplify into negative 1 plus or minus I square roots of 5, all divided by 2. Negative 2 divided by 2 is negative 1. 2i times the square root of 5 divided by 2 is I square roots of 5. And 4 divided by 2 is 2. So they all simplify down. Okay, in my class, I kind of have a hard time believing that I would not give you full credit if you were able to get to this. But technically, this would be the most simplified version. Okay, this one I did have to take the square root of a negative number. My discriminant is negative. That tells me I have 2 complex solutions. Okay. Okay, looks like we just have 2 more examples to go through. All right, let's do these 2. Okay, looks like it's probably going to be the exact same thing here. My guess is that this one here, I'm probably going to end up getting a complex solution as an example. But you already saw that, so hopefully you all can keep up with that. Minus 4x plus 8 is equal to 0. Okay, so that means my a value here is 4. My b value here is negative 4. And my c value here is 8. So that means I'm going to get x is equal to the opposite of b. So the opposite of negative 4 is positive 4. Plus or minus the square root of b squared. Minus 4 times a times c. All divided by 2 times a. Okay, so here I'm going to get x is equal to, well, let's go ahead and figure out what that discriminant is. Okay, negative 112. So 4 plus or minus the square root of negative 112 divided by 8. All right, so I need to start figuring out what divides into 112, what perfect squares do. So we're going to divide that by 4 and get 28. And I believe 4 divides into 28 again. So I'm going to try 16 now. See, because that's a little bit larger one to see if that divides out, which it does. So that's perfect. So how we're going to simplify this, that's supposed to be a negative sign. This simplifies into the square root of negative 16 times 7. And again, I picked negative 16 because that's the largest perfect square that divides into 112 that I can identify, which means this is the square root of negative 16 times the square root of 7, which means this is 4i times the square root of 7. Okay, so that means I can simplify this. X is equal to 4 plus or minus 4i square roots of 7, all divided by 8. And again, if you're able to get to this point, I'm probably giving you all the credit in the world. But each term here looks like it's divisible by 4. This term and this term, both of them are divisible by 4 since I'm dividing by 8. That means I think I can simplify this fraction. So 4 divided by 4 is 1, plus or minus 4i square roots of 7 divided by 4 is I square roots of 7, and then 8 divided by 4 is 2. Okay, my discriminant was negative, and I ended up with I as a part of my solution. That means I have here 2 complex solutions. Okay, why don't you take a moment, try C on your own, and then that will be the end of this lesson. So I'm assuming that you've already tried this. You're just here once again to check your work. So we are going to add 8x and 1 to each side. So now we're getting 6x squared plus 8x plus 1 is equal to 0. Okay, so that means my A value is 16, my B value is 8, and my C value is 1. So then I can just use the formula. X is equal to the opposite of B, which is negative 8, plus or minus the square root of B squared, so 8 squared, minus 4 times A times C, all divided by 2 times A. All right, so X is equal to the opposite of B plus or minus the square root of by 32. Let's figure out what that discriminant is. So 8 squared minus 4 times 16 times 1, which is 0. Okay, so then I'm going to get X is equal to negative 8 over 32. Okay, 4 divides into each of these. 8 divides into each of these, right? Negative 8 divided by 8 is negative 1. 32 divided by 8 is 4, so negative 1/4. Again, I've shown you how to do this before, but if you take negative 8 divided by 32 and then hit math, fraction, it will simplify your fraction for you also. Okay, so what does this mean? This is my solution here. My discriminant was 0, but that means I lose my plus or minus, meaning I'm only going to have one answer, and so that means I just have one real solution. Okay, so that's the end of this lesson. One thing that I would tell all of you and encourage all of you to do is that this quadratic equation works for any type of quadratic equation. All you need is the A value, B value, and C value. So what I would highly encourage for you all is if you are doing like a word problem and the numbers are very large, so it's pretty tough to factor. Like if you're looking for numbers that multiply to like 332 and add to, some other pair of numbers, instead of taking all the time to find those combinations, to find the factors, to set those equal to 0 and solve for each x value, you do have this in your back pocket. You can use this for whatever method you need. So if you're doing word problems and when it comes to testing time, I don't have a required method of solving these equations. As long as you can, write the equation and then solve it in whatever method you want, that's all I really care about. So if I'm looking at this here, if you can write the equations, go ahead and use the quadratic formula if you wish to solve. Otherwise, that is all I have for you today. I will see you next time for the last section of Chapter 4, which will be, looks like, systems of nonlinear equations. Otherwise, go ahead and start the homework, and I will see you next time.